Hello and welcome, and if you are following this series, welcome back. For those who are new here, or for those who have gone through my videos, what we have done till now, we understood about difference between supervised learning and unsupervised learning. In our first video, what is clustering, what is unsupervised learning, how many types of clustering are there, and what is the difference between them. And we get to know that there are two types of clustering, which is hierarchical clustering, and then there are partitional clustering. Then hierarchical clustering is divided into agglomerative clustering and your divisive clustering. And in our partition side, we have k-means and then fuzzy c-mean algorithms. This was the content for our first video, which we discussed. In second video, we discussed what is these library, these library do, how we can import our data, how we can get an information of our data like these, how we can get these, how we can use our data to leverage our machine learning model. We made labels out of our data, which is quote unquote to work with our data, to know our data, to have something which we can use to produce in like we can use in our unsupervised learning. But again, the difference between supervised learning and unsupervised learning is that unsupervised learning doesn't have a data which is given to our our raw data format. So then we printed some unique values. Then we went ahead and we worked with our data to plot some graphs and to get some features out of it, and to get get to know about how many features and how many rows and columns of features we have. In this video, what we will do is we will go ahead and we will go and finally start coding or taking will take this all information which we have collected in previous video, and we will feed it into our agglomerative clustering algorithm to get the result which we want, and to actually see unsupervised learning in action. And if you want to watch those videos, first and second video, I will highly recommend it, because there are a lot of information which is useful for you. And if you don't want to watch, you can follow along. But if you want to watch it, and I will highly suggest you to do that, because that makes picture more clear. I will tag those videos in my I button and in end card of this video. We have done this. Now, as as I said, that we will use Scalar Library, which is scikit-learn library. So what is Scalar Library? So Scalar Library is actually a collection of, let's say, important algorithms which we can use to perform supervised learning or unsupervised learning. And it is a very powerful library, and we use sklearn for clustering. You can do clustering by n number of method, but here we will use Scalar Library. And again, Scalar Library is very powerful library which have a collection of algorithms which we can use to perform our machine learning task. So we will say from Scalar this dot clusters, because we are working with clusters. We have a Scalar library which have a cluster which have the property of agglomerative cluster. We will say from Scalar dot cluster import agglomerative clustering, CLUSTRING, and we can say one more thing from Scalar. We want to have, if we use clustering, as we have discussed, that we divide the whole cluster into small parts, or we take small parts or sum them into a bigger part. So if you can put this information into perspective, you can see that there must be some difference, there must be some distance between two clusters. So let's say there is one cluster, there is this cluster. this here is the distance between two clusters. Let's say this is one cluster, this is one cluster, this is one cluster. So the space between them is the distance between those clusters. And if we are saying that we are merging that, we have to calculate the distance. So we will import a pairwise distance property from sklearn, and which comes from sklearn.matrix matrix import pairwise distance. Let's import it first. It can take time, and if you have not, like if you didn't have your sklearn or scikit-learn library installed in your Jupyter notebook, that this can show error, because you have to first install or pip install your sklearn library. So let me show you how to do that very quick. So I have installed in that. Go ahead and, like, you can say pip install sklearn, and it will give you this installing scikit-learn library and how you can install scikit-learn library. So, or you can follow this documentation from here, or you can go ahead and write pip install your library in Jupyter. It's taking time. Let's see. So it is importing right now, like our okay, there is some error here. What is that error? I think that is clusters or what. Let me check with clusters. Okay, let me check again with spelling mistakes. Agglomerative. So like, be careful with your spellings, because yes, this can give you error again. This should be clusters. So yeah, now we have successfully imported our two features from our sklearn library. Now work on it. Let's work on it. Let's say we have a model variable, and we will say that that model variable will take agglomerative. I have to be extra careful with the spelling, because that can show error. It will take agglomerative clustering, and it will take n clusters. N clusters is how many clusters you want your data set to divide, and I will go for 7 clusters. You can play with this. This is actually parameters which you can play and see how good your data sets turn out to be. But I am going for 7 clusters, n clusters. Then we are saying linkage, average, and you can find about these parameters in very depth when you search for agglomerative clustering. But in very basic information, this is like number of clusters you want, linkage, what type of linkage you want. I'm going for average, like I want average between. I want our linkage to be of type average. Then I will go for affinity. Affinity is basically with, like, we have a sine property, we have cosine property, trigonometry, because again, in very broad perspective, all we are doing is performing some maths with our data set. To be very honest, machine learning is just a combination of matrix, statistics, and probability to get predictions from our data set. So we are just performing mathematical operations on our data set. And cosine, if you have basic understanding of trigonometry, you know what cosine is: sine, cosine, and tan values. So we are saying that we will go for cosine affinity. Again, if you want to read about this in depth, you can find that documentation on sklearn agglomerative clustering. But again, if you want me to show you here only, let's go for that. So here is how to install your sklearn. This is a documentation to install, and here is how you can pip install. You can pip install by saying pip install scikit-learn, and this should install your scikit-learn library. And let's say we want documentation on Learn, again with the spelling MERATI. So yeah, by default you can see that n clusters is 2. Affinity is a string or callable matrix. Matrix is used to compute the linkage that can be Euclidean. Euclidean is different, like between if you have like read a distance formula, you know what is Euclidean distribution formula. It is under root something x minus some value of square and plus something something something. Then these are value L1 value, L2 value, Manhattan value, and cosine and pre-computed. So you can use between from this, and it actually calculates the linkage between your data. Then here is what I have used linkage, based on your criteria. Like you can use the linkage. I have used average, uses the average distance of each observation between two sets. So I'm like the average between two data sets. So there is that. So yeah, if you want to read more about it, here is the documentation, which is scikit-learn.org, and or you can Google it, or like how I googled it, and you will get to this documentation. So I think now you understand what is linkage and affinity means. So I'm making a model which will take a parameters of n clusters, which is 7, linkage like average, and affinity of cosine. And now let's go and fit our model, and we will say model.fit features. Okay, features. So and we will say let's first fit our model. So this will actually take features and try to fit our model with these property which we have given, and then after that we will go for label, which is here. After fitting that data, we will take label, and we will see how we can perform some operation so that we can get some useful information out of this code which we are writing. So like I think our model dot fit worked, and let's go and take label model dot, I think labels, model dot labels, and we will say that first showing the unique values, and period dot unique, and QUE unique, and model dot address. So again we are getting the same information of like 1 2 3 4 as previous, and yeah, these are the unique values. We cross checked it. Let's say we want our labels to be label is equal to label, and like see, I'm performing all these operations to actually get the meaningful information out of our data set. And this is like when you get different kind of data set, you have to perform different kind of feature engineering, exploratory data analysis, EDA, which is a fancy term to say that find some useful information from broad perspective of data, and just find some data which we can use to make our machine learning model. All EDA, which is exploratory data analysis and feature engineering, all these terms basically means that filter your data in such a way that you can make a useful machine learning algorithm out of it. Like let's say I have a roll number, I have a name of a student, I have a age and sex and everything. Like let's say in which school he goes, and is there like he is a single child, or he has a sibling, or he's a single mother, like he has a single mother or a single father, or like both of the parents are there. So if we have these kind of data sets, like we have all the information of this, and we want to like give some, let's say, benefits. Let's say we are distributing some benefits which we received from our government to distribute between students. How we can do that? In that case, we don't want any information that whether he has a single mother, single father, or anything. Like we can use in some another form to find some another thing, but in this case all we want is row number, and we want a name for our student to check whether the beneficiary got the benefit of that scheme which government ensure us to provide them. So in summary, all I'm saying is find some useful information which we can use to make a good and meaningful machine learning algorithm, and we can find some data out of it. So all ED and feature engineering in in machine learning boils down to this. So yeah, I'm saying that we want labels, and labels will be labels minus 1, and let's put it in this cell only. Okay, now we want a mean square. What is a mean square error? What is a mean square error? Let me go to our this, and let's go for square error machine learning. Okay, this is some fancy diagrams. Okay, these are the formula of mean square error, but in very basic sense, let me tell you what is this. So as you can see that these are our values present. Okay, these are predicted value which we thought that we will get. Okay, this is in the context of supervised learning, so they are showing the regression line. These are regression line, like these are the difference between what is a predicted value, what is a real value. So all you can see is that the difference between these like predicted and observed value, there is like some distance and some sort of error which we are getting, and that is actually known as mean square error. See, like we want our error to be minimized, so we take the square of our error and then we take a mean of that value. So that is known as mean square error, and we do that to minimize the risk of our data and the error present in our data, so we can get some good machine learning and significant model out of it. So we will go again from Scalar.matrix. Again, matrix is a library from sklearn, which is in very basic sense we use to perform complex mathematical operations out of it. So from Scalar.matrix import, we want a mean underscore square SQU array. Again, be careful with your spellings, or it will show errors. So we want the prediction for our how good our data or machine learning algorithm is, or how good our agglomerative clustering is. So we will say, okay, I'm taking this mean square error, give me a score out of it, of all this data, imply this to all this data, and I want a score. So we will go and say make a score variable mean. Let me first import it. If there is any error, then we will get here only. Okay, so we successfully imported it. So I will say score is equal to mean square error, mean underscore SQUARAD error, mean square error. Again, we will take labels, which is here. Okay, and we if you want to see where the labels came from, it is here. Okay, we will take labels. because again, as you can see, we are working here with features and labels. So we will take labels and we will take model dot labels. So we actually took our data, we feed it into our model variable, and we fit that data to our we fit features to our model dot fit variable, and we actually took label and we have given that value to our model. Then we said okay, we have this model dot labels which have unique value of this, and where labels is equals to labels minus 1, and again we are taking that only, we are taking labels and model dot labels which we have, and we will compare the score between here, and we will say absolute error. What is absolute error again? Like it is like these all terms comes from mathematics. So I'm like explaining you as we go through every terms which we find out. Absolute error. So again, like what is absolute error? These all are some fancy formulas for absolute error. So again, it in very basic sense, it is about like how we can have our error minimized, and again mean absolute error, this only. So it is basically the same thing, mean absolute error, which I explained like 2-3 minutes ago. So I will say mean absolute error is equals to np dot square root sqrt dot square root, and we will say score. Again, score is coming from this. We have took the mean squared error of these all terms, we got some values, then we will say that score like square root that value which you got from these all things, and then it will give us absolute error of that, and then we will say print that absolute error which we are working with. Okay, and theoretically what we should get is how good is our agglomerative clustering algorithm based on all the data and the operation which we perform on our data, and how good and how better it is in predicting the value of unknown data. So we get this value. This is actually the score which we get by feeding all the information and using agglomerative clustering algorithm, and this tells us how good our data is. So here it is, like agglomerative clustering in action. So now you know how we can use agglomerative clustering to predict our data, and how we can find the score of our data from this agglomerative clustering algorithm, and how good it is for our data. In next video we will go ahead and we will use k-means, which is a form of partition clustering. So yeah, till then, be happy, spread peace, and peace.